All right. Good morning. Um, Hope you are enjoying the conference workshop so far. My name is Lakshmi Prasad. I'm an assistant professor and extension water engineer at North Dakota State University. Me and Steve will take you to the rest of the workshop today. Um, so it was nice to hear about the irrigation crop budgets and irrigation acreage earlier this morning. So now we'll continue with the workshop. Uh, it is my pleasure to introduce our next speaker, Josh Gelinske. So Josh is a CTO of Endeavor, an engineering and prototyping foundry focused on autonomous rugged systems for defense and agriculture. Josh also serves as a fractional CTO for the NSF AgTech engine in North Dakota, guiding the technical strategy and commercialization at the intersection of advanced robotics, AI, and production agriculture. So, Josh will talk about the operationalization, AgTech innovation, and lessons from the project Whitewater. Josh, all yours.
All right. Thank you, Lakshmi. And thanks everybody for coming today. I wish I could be there in person, but I am excited to talk about how the AgTech engine, Endeavor, and other partners are operationalizing AgTech innovation. And, first, we'll just kind of go through a little bit more detail and background and how this all connects in with a couple of the organizations involved. So starting out with Endeavor, the organization I work for, this is probably not an organization that you maybe are familiar with, but in its previous name, because we've recently rebranded, it was known as the NDSU Research and Technology Park. So that's several things. One thing it is about 55 acres of land just west of the NDSU campus, and we host, a number of companies, John Deere, AGCO, some NDSU research buildings, hotel, and then what we call the incubator building. Within the incubator, we support over a dozen startups from AgTech, defense, other industries, a lot of software and technology through our incubator program, as well as providing space for them. And this has been around for about 25 years. And in the early 2020s, we expanded that and put in what we call Innovation Studio, which is really a unique prototyping space for builders. Think of community members, startups, certainly students from the university, startups in our incubator, but also corporate partners that come in there. And it's an 8,000 square foot shop that has metalworking, 3D printing, digital fabrication, high bay. So you can, if you turn up there any day of the week, you might find somebody building on a robot or a frame for a piece of equipment or otherwise working on technology. And in September, we rebranded as Endeavor to really represent an expanded mission, working with industry, working with commercialization of university research and our work that we're doing with the AgTech engine. And the AgTech engine, also more formally known as the NSF AgTech engine in North Dakota, we'll often refer to it as just the engine. They were formerly known as FARM. So if you've heard that word, that's kind of all synonymous with the same organization. How that came to be was in 2024 under the Chips and Science Act. The National Science Foundation launched this really the largest place-based R&D investment in U.S. history, and they call it the NSF Regional Innovation Engines Program. So these engines are designed to drive economic growth, build innovation ecosystems, and address national security challenges throughout technology innovation. So there's a number of different focuses they can have, and North Dakota's is an AgTech engine and one of 9 inaugural engines, and it's advancing resilient, secure food systems, and really doing that through what we call use-inspired tech innovation. And great way to think about use-inspired, if that term comes up again, is it's really derived from a true need. So it's problem-driven, it's use case-driven, and it's also focused around workforce development, the engine that is, regional collaboration, and local economic growth. So really with the initial $15 million investment from the NSF, all this program was able to come to be, and Project Whitewater is one of its key impact projects. So, before we get into Whitewater and the project, it's really important to understand the system that we've built and we're building. And, as I talk through Whitewater, I'll talk about how that's, influenced the system that we have today and really what we've built here. And, you know, running through a few more definitions on this as well as we look at, this word translation. You're going to hear that throughout in a number of different ways. You'll also hear it as TIP or TIP, and that stands for Translation of Innovation to Practice. And really, what we're looking at with translation is how do we take technologies, research, innovations, and you know help bring them into and form them into something that's used out in the world. And a lot of that can be commercialization and commercializing those, which in fact, with new federal funding priorities and the NSF, and specifically again this engine program with its focus on economic development and focus on particular region of North Dakota, commercialization aspect of that translation really gets a lot of focus. So as we look at the overall system, and we kind of talk about this in terms of what we call on ramps into it and how things come into the system. And starting with research and researchers, we're really looking at those faculty driven discoveries and how they feed directly into this tip intake process that we'll talk a bit more about. And really the goal that's ensuring that, lab work, field work, all, kind of the academic and fundamental research doesn't just stop at publication. We really want to keep it moving forward. Another on ramp is provided for entrepreneurs and, really the startups, community innovators, perhaps even people that didn't think that they were going down that path. We provide mechanisms to intake and triage and really look at those community innovators and try to align their ideas with the resources of the engine, which includes all the partner organizations. And again, to try and keep that aligned, really the community, growers, tribal communities, industry feedback, providing voice of customer. And they're really able to, as stakeholders, shape the problem definitions, really help ensure that our translation targets are real adoption challenges, and we are working towards something that's really going to get out in the world. And the other thing I'd say about TIP is it's intentionally designed to be a pull system. So we want to pull innovation in, not kind of push it through. And part of that is meeting the innovators where they're at. And in this centralized process, we evaluate projects, we ensure they fit with the TIP's mission. And as we look at the intake criteria, that includes problem alignment, end user engagement, and potential for adoption. So it is far from, and definitely not just looking at the technology or the technical merit. And at the end of the day, this is trying to provide kind of the right door at the right time access. And whether an idea needs IP strategy, prototyping, maybe direct grower validation, actually getting out in the field and seeing how the product works with real people, we can attach and provide the right things. And if you look at the system and how this works, it builds efficiency. So innovators don't need to waste cycles searching for that support in their match directly. And as you'll see through Whitewater, it greatly speeds the process. So the other thing, kind of looking a little more at the intake and triage. So we have all those inputs coming in, voice of customer, really grounding, what we want to work on and how, and if it's a good fit and if it's going to address a real need, and coming out, a lot of the different things that might be utilized. Again, the validation, prototyping, how we go through different adoption pathways, and the pathways through here. There's kind of two main ones, but we continue to evolve and find kind of more ways through. One is through funded projects. A lot of that is it's structured funding that accelerates early stage research and translation, and it adds the accountability and milestones. So that's a lot of what we'd see probably at the academic and the university level. we're also planning and building for the future years what we call a seed fund. So that's really going to be the TIPS catalytic capital, and it's going to be able to provide a bridge between proof of concept and an investable startup. So kind of getting them through that valley of death where they maybe have the idea and something that's just barely working to something that's MVP and it's been proven some field validation and they can attract additional funding. Like I mentioned, we've tested this with a number of different project archetypes, and we're trying to see which paths require policy support, capital validation, even technical advice on how to industrialize things. And a lesson learned here is everything's a bit different. So different ideas need different pathways. There's no single template to translation, which is another reason why the engine has a very robust set of partners, Endeavor included. And as we go through this process, kind of the block at the bottom, the tip framework, we're continuously learning and applying those learnings to help us scale. So getting to now, the operationalizing that. So how did we run through this project? What is this project? And it's an exciting one to share because I've been with it from the start as the program manager for it. And I think what's interesting, it's not just the technology, but it's how we built and ran the project within this new model for ag innovation in North Dakota. And as we go through this project and this use case, it really represents how growers, researchers, and startups can work together through this engine framework and move from a problem that's identified in the field out to a scalable commercial solution. And I promise this is the last slide where I'm introducing another organization, but this one is key because this is the company that's at the heart and the center of this Whitewater project. So if you think back to the on-ramps, the pathways, this represents a startup that came into the system. And we'll tell a little bit more of the story going forward. But this is, as you kind of narrow down, think about that startup archetype working through the system. And what Aperture is, it's a company based out of Boston, Massachusetts. It was founded by an MIT PhD researcher in radar technology. And really, they're a data to service company that's revolutionizing agriculture, climate, and defense analytics. And what they do is really transform data to actionable services using satellites and a whole network of ground validation sensors and AI and machine learning. It's pretty exciting stuff, and they've been great to work with. So what is Whitewater? We can finally get down to that. And so again, players involved: AgTech Engine, Endeavor, Aperture, and Whitewater didn't start out, or Aperture and their technology didn't start out as a project at all. It originated from their radar analytics that they developed for aerospace and defense. And the startup was they were actually participating in an international accelerator program that allowed them to connect with a local grower in North Dakota of all things, even though they're in Boston area and going through a national accelerator program. They connected with Kyle Courtney here in North Dakota via a mentor that they met through that program. Through their discussions, he was able to introduce them to neighbors, Steve Hansen, which I'm sure many of you may know, and he's probably there today, and the challenges that they're facing. And this transpired probably just a little over a year ago, because the time scale is important as we tell this story. So it's just a little over a year ago that those introductions were made at a Grand Farm event in the Castleton area. And that's where he first met Holly, who's pictured on the left in the slide, Holly Mackey, the CEO of the AgTech Engine and the AgTech Engine team. So as we went through discussions, Aperture understand their technology, the problem, its potential application, bringing together the resources of the AgTech Engine, the partners. We formulated a plan to build a model of how can we help advance them through to the market. And that started building the system that I talked about earlier. It was really the template or pilot project that we ran through. And the engine provided the structure, validation requirements, and validation environments, excuse me, and technical support. So they were able to, you know, pivot this aerospace technology towards the AgTech problem and really move forward on that and advance it. And I think that really shows what the engine does best. It creates these translation pathways, and it helps turn those ideas from, coming from even unexpected places, right, into real on-farm tools. So there we have pictured Zach Kavalak. He's actually the founder and CEO of Aperture, and he's taken the right attitude. He's been boots on the ground here in North Dakota. He's been out on the fields, learning hands on day one, which has been the right way to do it. And really, when you look at the problem, I don't need to probably tell this group, but I always say, water is an extremely precious asset. And numerous studies have shown irrigation increases yield, 30 to 40%, and yet most can't irrigate due to lack of access to water. And we all hear about Nebraska's aquifers drying up, data centers consuming precious water from farmers in Arizona, Colorado, and beyond now as concerns. But we don't talk maybe as much about North Dakota. But here in North Dakota, 400,000 ish acres are irrigated, but I think a recent study determined that maybe 2.2 million or around there acres could be irrigated if water could be managed more accurately, more precisely. So one of the primary reasons why this happens is because those that do irrigate, they're tending to over irrigate, and certainly not because they want to be wasteful or they don't care about the environment and resource. Not at all. It's just they don't have the tools. They don't know the field moisture levels. The data just doesn't exist so they have to hedge a bit, and even beyond the hedging, there's certain areas that they just can't evaluate, so they kind of have to go with the basic application rate, which could be over for some of the areas, right? So we need to make that more efficient. There are ag data weather networks, and they collect soil moisture and rain, but those are very sparse. I mean, those aren't going to apply to your fields, and people know that. Soil moisture probes, another technology that's out there. They have their place, but they're expensive. You have to install, uninstall, and it's really hard to adopt those at a large scale. Now, looking at scale, there are technologies that can cover an area. NASA has satellites that can do this, but it's extremely coarse. And again, what that means is it's left to rule of thumb. It's left to experience, and it relies on guesswork to really understand how and when and how much to irrigate. So that's really where this project started, and not with the technology looking for a use or a solution, but it really was ground up from the growers and a defined need, and that was important to keep everything focused and practical. So again, as we look at this problem of scale, a number of those things coming down the middle, NASA SMAP, NISAR, etc., satellite technologies, and the sizes, the resolution over there. Think about that at 10 kilometer square, 1 kilometer square, 100 meter square. That's quite coarse. And really what customers want and need is down at that field scale. Certainly less than an acre, but probably approaching something around the order of 10 meters. So looking at the solution and where we came as a group to this, and where Aperture is able to bring their technology, they're taking advantage of a novel satellite recently launched by NASA, and it's using low frequency data, and that's able to penetrate crop canopies and into the topsoil, which is very important. I'll talk about that. And that's able to measure the water beneath the surface and content in the soil. And there are some drawbacks. The satellite only collects data about once a week. So what has to happen is fusing that measurement data, local weather, soil maps to understand soil type and the hydrology, as well as crop hydrology models, transpiration ration models coming together to build AI and machine learning models. And now we're able to predict, a time step ahead. So what's able to happen is Aperture is able to produce daily, near real time 30 meters. So again, going back to that resolution, 30 meters. So getting down below that acre where people want to be, resolution soil moisture maps. And they're deploying that out on a cloud-based platform. So growers can log in, they can see their current field conditions, they can get irrigation recommendations across all the fields, which again is another key that we kind of came down to where, okay, it's great to maybe have some things that are telling you the moisture content, but what does that really mean as far as what we should put down as far as additional water? So that's where that recommendation comes in. It's not just the measurement part, it's actually helping you take action. So through all that, I mean, we essentially took this space grade analytics and simplified them down, put a lot of automation in so that everyday decision making is able to put that directly into the hands of local growers. I'm not going to get deep into the tech here, partially for time and partially just don't want to go too deep on that stuff. But it is important to think about, how does some of this work, the radar, and when we're talking about that, radar can operate across a number of different frequencies, and what that's really changing is the wavelength of that energy that's emitted, and from a very long wave L band, which is being used in the case of this project and product, to X band, where maybe they're using more for synthetic aperture radar, where you're actually trying to image from like a visual image, turn it almost more into a picture with that higher frequency, shorter wavelength. But there's drawbacks to that. You'd say, well, if we want this high resolution, why don't we use that? But the thing is, with those wavelengths, and again, I won't get into the gory details of RF and physics and things like that, but the higher frequency, shorter bandwidth just can't penetrate. So that's going to get reflected by foliage, crop canopy, different things like that. Whereas when we go into the L band, we actually get penetration so that, once your crops canopy out, we're still able to penetrate through them and get down to the soil and get a measurement. So, okay, so how does this part work? So, soil has different levels of moisture, obviously, and as that changes, it changes the dielectric, essentially of that surface of that structure. And that again depends on the type of soil and different things. So that's why it's important to also have the soil maps. But the general principle of this is, sending that radar and that energy down, and then looking at the reflection and the reflectivity of it as sort of a core signal of this. And as you get more dry, you're not going to reflect as much. And as you get more wet, all the way to completely inundated and across that whole spectrum, we get a varied reflection. So that's what's able to be used as sort of the core moisture signal, but it needs to be paired with a lot of other modeling to get it accurate and get it right. And that's been done. So what we end up getting is, again, with that irrigation recommendation, you can see we get down to a subfield level. So we can, not only understand how that field looks, that section, but we can also see, within there, how we might want to apply different levels of irrigation. And, this goes back to, again, I think about, precision agriculture. I've been doing this for a couple decades in industry prior to being at Endeavor, designing products, releasing them. And we always see this sort of chase and sometimes leapfrogging of, we may have a particular problem where, we can control something very absolutely. I go back to the example of like a multi-hybrid planter where you can put, more than one variety of seed into this planter. And we have the technology that we can place those seeds, the right depth, the right spacing, the variety of seed where you want it to go. But we haven't had a great technology in that case to say, well, which seed should go where, right? So you need the prescription to go along with that. I think we kind of flip that around, and a very similar thing here where, you know, the irrigators and the automated irrigators have had ability to do variable rate irrigation for some time. And you can put in a prescription, and it will, dutifully and faithfully apply based on that prescription quite well. But how do you know what that prescription should be? That's the question. So that's where things kind of chase from our ability to control versus our ability to sense and measure and recommend and predict. So I think, this is aligning on the irrigation side with a place where we have the ability to control. We don't have the ability to really sense and predict and provide the recommendations until now. So I think this is going to be a game changer. And some of you may have been involved in the water tour that happened this summer, and we went out to Steve's. It was great to bring everybody together and just see all the general innovation that's going on around irrigation. And I think it shows you that the work that's being done in this project. I think what another thing that's really special about it is how we're working. Steve, Kyle, some of his neighbors, other folks and growers that were participating in these projects, they were really part of it. I mean, we met every 2 weeks. We had the engineers, the scientists, the growers all together, and you kind of see some of those results. And if you were at the tour, you saw kind of a midterm update, but that continued through the summer as we continued to iterate, and now we're in a place where we've gone through that last season. We deployed 22 sensors across North Dakota with growers and out at Grand Farm and one of the RECs. And that really allowed us to get ground truth data that we could continuously validate the satellite models, have that feedback loop, continue refining them, work on the user experience of the cloud-based system with the growers. And, that was essential. It also gave us something really instructive to better understand problems and limitations of the ground probes themselves. Whether that was in heavy clay out in Castleton at Grand Farm, when it dried up and that really hydraulic soil pulled away from the sensors, and now we lost the contact. We had errors with that. We had installation and other calibration things. So there certainly is a place. I'm not trying to knock the soil sensors, but they come with their own complications and limitations. So again, through that work, did a lot of evolution. But in addition to, a lot of the technology, the product, kind of how people use and experience it, along the side, we also worked with Aperture really to understand, okay, now that this product is coming together, where's the market, who's the customer, really working on go-to-market plans. Are you going to sell this through precision AgTech dealer, co-ops, try and go direct to grower with kind of a SaaS solution? Will you just take the data, bundle it up, and sell it to companies that may use it and incorporate it into their products? There's a whole spectrum to be considered, and they really needed to do some soul searching and understand from themselves too what kind of company they wanted to be and how do they want to bring this company to market. And through a group and through our partners and advisors and working with them, they have a path forward, and in 2026 they're going to be going to market with the product. So it's a pretty, again, in a couple decades working in precision ag tech and bringing products to market, pretty incredible advancement and the pace that we're able to move them along in that time. If you think about it's going to end up being probably a 12-month period from when we really engaged them in the project. We met them before that, but when we engaged them in the project to when they're going to be out in the field. And that's really what it looks like to do this and advance, and what we look to do in the future with even more and more projects and startups. So when it comes to kind of getting towards the closing, when we think about innovation, it really starts with a question. And in this case, for two North Dakota farmers, it was how to irrigate more efficiently. And by connecting their idea with the tech company Aperture's soil moisture technology and the NSF AgTech engine and partners were able to turn that into an answer via the project Whitewater and the product that came to be from that. So I think it's done many things, but it's helped really refine an important model that again, as we try to operationalize this, how can we really support these companies, researchers, and other folks to get their solutions in the hands of people where it can make impact and do that as quickly and as with as many as we can. So wrapping up on that, it was great to talk through. And if you'd like to scan the QR code, you can keep up to date on the evolution of Whitewater and where we go with that. And in general, what we're doing as part of the engine. Other startups will look through, or if you want to get a hold of us, if you have some of your own ideas or technologies, if you see yourself in one of those on ramps or somebody reach out and connect with us. Thank you.
Spatial level soil moisture, especially in the crop root zone, is a challenge, and leveraging the large language models and artificial intelligence is a great way to address this problem. And these tools can certainly advance the science of irrigation and crop water management. So thank you very much for presenting all that information and interesting ways of how you're using the NASA and other space agencies products to address the irrigation water management. So we have a few more minutes to take questions, and before we get into the break. So please raise your hand. We'll bring a mic so you can ask questions to Josh.
Does anybody got questions? The first thing that I'm going to bring up, and Josh, thanks for your presentation. So, I think all of us here, unless we're around the Missouri River, I know Sharon is, but, you know, at the end of the day, we're all looking for more permits. I mean, that's really when I got introduced to Zach and then with Josh's leadership, to get this thing going. The Department of Water Resource is, when it comes to issuing permits, they deal with water supply. Okay, they look at aquifers, and in some cases they're saying that aquifers are appropriated out. Okay, are they? Well, who knows? But we as appropriators, irrigators, we have to do our due diligence too. And if it's adopting technology to put the water where it needs to be, my hope is that if we're willing to adopt this technology based on science, based on data, we can get more permits. Okay, that's really my goal. And then this just kind of fell in here, and we're testing it. The DWR is aware of this. They in the near future, I would say within the next week or two, he will I think Zach, probably not the next week or two, but after Christmas, he will be coming to North Dakota to sit down with the DWR. Reese and his team are very interested in this. They were down at Oaks this summer at the water tour to check it out. Granted, it's not a perfected product yet, but I think that's the big question myself and a lot of other people want is we want more permits. And yeah, we think the DWR is being very conservative on handing out their permits. So, with that, Zach has asked me too. A few of you have been contacted in the room by Zach, and he's looking to talk to any and all irrigators in North Dakota to find out how you irrigate. One of the challenges right away was being able to, from a PhD guy talking to farmer. It was a challenge, and Josh really bridged that for us. Because I don't talk on his wavelength, and he didn't understand you could reverse a pivot. Okay, he didn't know that, but how would he? So that's some of the hurdles we had to get through, and by asking the right questions, and that's. But Zach's a smart dude, and he has really, latched onto this, but anybody, a few of you he's contacted in the room, anybody, if you're willing to give your number to have him talk to you in person to understand how you irrigate, will help perfect that product. And so, yeah, I guess my hope is down the road, it will help. The DWR will adopt it. I hope NRCS adopts it because, like Josh said, and I agree, it's going to be a game changer in the industry. Zach and I are speaking at the Irrigation Leader Convention down in Phoenix in January. We specifically got asked to do that based on his technology. So it's different than anybody's in the industry with his L-band radar. I did have a variable rate pivot, yes. However, with his app, you do not need to have a variable rate pivot to do this because we all know how expensive that is. You know, is it going to be perfect? No, because it's all pie shaped. We know at the end of the irrigator, it may be low ground. We don't need to irrigate as much, and if we don't have VRI, we can't slow that down. So he's going to develop it on a pie shaped basis. So it's the closest we can get until more technology comes along where we can variable rate without the expense. Okay. But yes, what he was looking at down in the Oaks area was on 2 variable rate pivots. He was also, we had sensors on non-variable rate pivots. You know, and once again, I agree with Josh. I don't want to sit here and slam sensors, but they're very unpredictable, and it's one spot in the field. So in my instance, I'll run the variable rate around and I put a 1/2 inch on, ran my variable rate, then I ran it regular, put a 1/2 inch on. I saved 640,000 gallons of water in one pass. Now, with Zach's technology, in my opinion, now I can't base this off a fact, but because the sensor isn't perfected yet, 25 to 30% water savings. That's as near as I can tell on my one field based on how I irrigate. Anything else? All right. Thanks, Josh. Appreciate it.
Thanks. Sorry, I got cut off for a few minutes there. Not sure what happened. But
oh, okay. Go ahead.
Thanks for it.
We got one more question. Go ahead, Scott.
Sure.
Yeah, that you are correct in what you're saying. Yeah. Some of the older pivots, I mean, yeah, you're going to have to retrofit that with a new panel. Yeah. Yep. Right. Then the VRI. Yes, correct. Yep. Yeah. Okay. Josh, I was just telling him how the bridge between PhD to farmer and how you bridge that for all of us to bring us all together and keep us on task. So appreciate your leadership on that.
Thank you. Oh, it's been great to be part of.
Thank you.
Thanks, Steve. And thank you, Josh. Thank you, everyone. Thanks for your participation and interest in this presentation. So we'll take a break and we'll gather here again at noon for the membership meeting. So the lunch will be a working lunch. So get your food and come back and join the meeting, association meeting. And following that, we'll have a board meeting for Irrigation Association. And we'll have another presentation in the afternoon. And Steve and I'll take you through the rest of this workshop. And thank you very much.